Good day everyone and welcome once again to my channel. It's been a while. All I can say is I'm back. Now, we are going to be looking at the initials of chemistry, talking about foundational areas of chemistry. So for those of you that are preparing to writing the forthcoming JAMB WAEC examination, I would advise that you stay glued to this channel, check other videos that I've posted previously to enhance your learning process. So on the board, we are going to be looking at three terms in chemistry that most students they mistake one for the other. So I'm going to clarify it. So all you need to do now is just to stay glued as I run through it. So considering these three terms, we have valence electrons, we have valency, and we have oxidation number. These three terms are terms that most times students, when they are confronted with these terms, they mistake one for the other. So let me try to break it down. Starting with valence electrons. What are valence electrons? Now, valence electrons are simply outermost shell electrons. They are outermost shell electrons. So valence electrons, they are outermost shell electrons. All right. So that's what valence electrons represent. Outermost shell electrons. Then what about valency? Now, valency is simply the combining power of an element. That's what it means by valency, or the combining capacity of an element. Then what about oxidation number? Now, oxidation number is simply the charge an element carries, or possesses. So these are their definitions. But I'm going to explain them one after the other, starting with valence electrons. Let's take a case study, sodium as an element. Now, sodium is with the symbol Na. What is the total number of electrons of sodium? It's very easy to get. How? Now, you should know that the position of sodium in the first 20 elements is in the 11th position. So that indicates the number of electrons. Of course, that's also the proton. So the number of electrons of sodium is 11. Now, considering it to be 11, then let's focus on the valence electrons first. Remember, valence electrons means what? Outermost shell electrons. In fact, the word valence in this context means outermost shell. All right. So, of course, these are things that you should be conversant with. The first shell here happens to be K shell, this happens to be L, this happens to be M, it continues. Now, the K shell takes maximum of just 2 electrons maximum. So since we are dealing with 11 electrons here, I have to put 2 in the K shell, while the next shell being the L shell takes maximum of 8 electrons. So I have to put 8 electrons. So I'm still left with 1 because I've just filled 10. So I'll put the last one in the next shell because the other shell is complete in that it has 8 electrons. So if I want to represent the number of electrons per shell, I will say 2 electrons is in the K shell, 8 is in the L shell, then the last one is what? 1. Now look at it, 2, 8, 1. First and foremost, if you are told we have 3 shells here, the innermost shell is K, while the outermost shell is M. So if you are now asked, what is the valence electrons of sodium atom? It's very easy. Since we have the outermost shell to be M, how many electrons is there in the outermost shell? So it's very easy that it is 1. It's obviously seen to be 1. So hence, the valence electrons of sodium will be what? 1. Is that easy? What about you are given another element? Let's say we are given neon. Neon. Now, neon is with the symbol Ne, having a total number of electrons of 10. So in this case, if you are told to fill the shell configuration of that, it should be 2 in the K shell, then the next would now be what? 8. So 2 plus 8 will give 10. But now, If we are asked what's the valence electrons, remember valence electron is outermost shell electrons. So in this case we have two shells, but this is the outermost shell. So hence how many electrons are there in the outermost shell? 8, because it's 2, 8. So 8 will now become the valence electrons of neon. Is that easy? So for that of valence electrons, there are no more stress on it. The only one that has little stress is on valency and oxidation number. So let me clarify what each of them represent. Starting with starting with valency. Now, what is valency? Valency simply is the combining power of an element. But if a student is being asked to explain that, I guess it will be kind of challenging. But let me break it down. Now, if I say valency is the combining power of an element, that's like a conventional way of saying it. But if I want to give my own standard definition of valency, I would simply say that valency refers to the total number of electrons an element needs to lose or to gain to become stable. I will take that again. Valency refers to the total number of electrons an element needs to lose or to gain to become stable. Literally in the world of chemistry, so many elements are very unstable. So they want to attain stability. So it's either they are donating or they are accepting electrons. You understand? Now, if you take your mind to chemical combination, talking about chemical bonding, the reason why there is formation of compounds is actually due to the instability of elements, meaning elements are literally unstable. So due to the fact that they are unstable, they are trying to attain stability. That's the need for them to say, okay, let us form compounds to become stable. You understand? So coming back to that valency that I defined, the number of electrons an element needs to lose or to gain to become stable. So if you are a very smart student, you are supposed to know what I meant by that. And again, which group of elements are supposed to lose in order to get stable? Of course, it's obvious it should be for the metals, because the metals are supposed to be the ones to lose in order to become stable. Why? Losing simply means you have excess, so you want to give out. So those ones that have excess, like electron-rich elements, they are actually seen to be the metals. So they have excess electrons that they can give out. They are seen to be the rich ones. You get the point? Then for the non-metals, they are the ones that are electron deficient. So they are always in need of electrons. So it means those ones, they need to gain in order to become stable. So let's still take this case study, sodium, Ne. Remember that sodium has 11 electrons in total, and we just said that sodium has the valence electrons of how many? 1. Then what about the valency? Remember I defined valency as the number of electrons an element needs to lose or to gain to become stable. Since this guy happens to be a metal, remember I said the metals are the ones that need to lose because they have excess that they can give out. So since it has excess, let's see something. Normally when we drew the shell, it was something like this: 2, 8 and 1, 2, 8, 1. So how many does this guy need to lose in order to become stable? Of course, every element is trying to attain stability. And what's the stability all about? They are trying to attain the octet or the duplex rule of stability. By octet simply means an element is supposed to be having 8 in its outermost shell. Then by duplex simply means 2. So it therefore implies that for those that are duplets, it shouldn't be more than two elements: hydrogen, helium. Because judging from that, hydrogen has 1 electron and it ends in the K shell. So it means it should be in need of 1. That's for the duplex rule of stability. While that of helium already is actually stable. So that's why you see that the group 8 elements are literally stable elements. Alright. So in case you are asked, what's the most stable group of elements in the periodic table or in chemistry, is actually the group 8 elements. So let's come back. Now, this guy needs to lose 1 for it to have 8 in its outermost shell. So if it gives out this 1, then of course that should be its valency. But remember I said the number of electrons an element needs to lose or to gain to become stable. So hence it needs to lose 1. Valency will now be 1. Now, what about oxidation number? Now, oxidation number is the charge an element carries or possesses. Now, can I tell you something that it is oxidation number that explains what has taken place in valency? What I meant by that is very easy, simple. I just said that valency refers to the number of electrons an element needs to lose or to gain to become stable. Since this guy is losing, how would you represent it? Of course, it should be written as Na plus because this plus implies it has lost one. If I write something like this, Ca2 plus, it means calcium has lost two electrons. If I write Al3 plus, it means aluminium has lost three electrons. So when you have that positive sign, it indicates or implies that an element has lost electrons. Then what about negative? It means it has gained. All right. So coming back, there was need for this guy to lose electron in order to become stable. That was why I wrote the valency as 1, meaning it needs to lose 1 to become stable. Then what about the oxidation number? Oxidation number will now show us that there was a loss of electron by using what sign? A charge sign of positive plus 1. Remember that it lost 1 to become stable. So losing 1 simply means positive. That's the charge you are supposed to use. So in this case, what do you observe? Can I say that oxidation number is valency plus charge? Yes, it's very correct. So the relationship between oxidation number and valency is that oxidation number is giving us valency plus charge. And you know that the charge could either be positive or negative. It all depends on what is taking place on the element, whether the element is losing. If the element loses electron to become stable, you use positive. But when the element gains electrons to become stable, then you use negative. So in this case, the valence electrons, the valency and oxidation number is 1, 1 plus 1. Then let's see another element. Let's try this for aluminium. We'll check the valency, valence electrons and oxidation number. So valence electrons first, valency and oxidation number. Let's go. Now, aluminium has a total of 13 electrons. So let's draw the shell. 2, 8 and 3. 2, 8, 3. Looking at this, what's the outermost shell? This last shell. How many electrons are there? 3. So what should be the valence electrons? Remember, it's outermost shell electrons and it's valence electrons. So you write your 3 there. Very easy. What about valency? Now, does this guy need to lose electrons or to gain to become stable? That's what you should ask yourself. Being that this is a metal, it needs to lose. And what is it losing? It needs to lose this 3. When it loses this 3, then it will now be left with 8 in obedience to octet rule. Remember I said you must have 8 in the outermost shell for you to become stable. So if this guy needs to lose this 3, then the valency should be also what? 3. Then what about the oxidation number? Remember I said oxidation number is valency plus charge. So anything you have written here, the shortcut is anything you have written for valency, repeat it here for oxidation number. The only difference is that oxidation number will now show you what has taken place, that okay, there was a loss of 3 electrons. So in this case, you now put your positive. Remember that positive means loss. I hope this is clear. Then let us look at another element to better understand this. We've been working with metals all the times. And of course, some students in their mentality now is um all the numbers must be the same. The first one that we did just now was sodium. It was 1, 1 plus 1. This one now is 3, 3 plus 3. So in the mentality of so many students right now is that everything must always have the same number. It's not everything that must have the same number. The only two that should have same values are valency and oxidation number. Judging from what I said, that oxidation number is valency plus charge. So let's see chlorine, Cl. Cl has a total of 17 electrons. So let's get the valence electrons, the valency, and the oxidation number. So looking at chlorine, let's draw it. 2 in the K shell, L shell will take 8, then M shell will take 7. So this is 287. Now, what is the valence electrons? Now, it's very easy. The valence electrons will be 7 based on atom motion electrons. Then, does this guy need to lose electrons or to gain to become stable? Of course, this happens to be a non-metal. You cannot look at this and say it should lose 7. To which element? You don't have it in chemistry. So the only thing that can happen here is for this guy to become stable, it needs to gain 1 to become stable. So this becomes 8. Alright. So gaining 1 simply means valency should not be 1. Remember what I defined valency to be. Number of electrons an element needs to lose or to gain to become stable. In this case, this guy needs to gain 1. So that's the reason why the valency is 1. What about the oxidation number? Remember I said anything you've written for valency, repeat it here, write the 1 and then next. Was there a gain or a loss? Of course, there must be a gain for it to be stable. So, are we to use positive or negative sign? Negative sign. Why? Because there is a gain. So, looking at this now, you would notice that the values are not the same. 7, 1 and -1. The only two values that are the same there is the valency and the oxidation number. So, don't forget that. So, it's my hope that I've been able to explain something with regards to these three quantities in the world of chemistry, talking about valency, valence electrons, and oxidation number. I hope you've learned one or two things from this lesson. So if you find this lesson helpful, please give it a thumbs up and then you can invite your friends to be a member of this channel. You are yet to be a subscriber, do well to hit the subscribe button and stay tuned as more of these kind of interesting videos will be dropping very soon. Stay glued to this channel and thanks for watching.